Jason Taylor's clean architecture. It's so much more than just a way to organize your projects. This video is about how I look back on the clean architecture template, how I used it in my first serious project, and how I'm still using it but slightly adapted to my needs. I'll start off with the first project, which is now 3 years ago. And then I'll follow up with the project I'm actively developing. So for the first project, I even used the same folder names. And I learned so much from diving into the code of Jason Taylor. So let's start with the domain. So the domain layer holds enterprise-wide logic and types like entities, enumerations, exceptions, value objects, logic and interfaces specific to the domain layer. So the topmost layer. The domain layer, I said the topmost, so it does not reference another layer. It does not import anything from another layer. For me, there's just some entities in here, a lot of entities. Some constants, which are basically, just public constant strings values instead of the enumerations. Some enumerations as well, maybe, but I'm not really a fan of the enum types. And uncommon has some inheritable abstract entities. Not as much as I just summed up. No exceptions, no interfaces, no value objects. Then let's head over to the application layer, which would hold the business logic and would reference, so import from the domain layer, the top. So this would hold all the features, so the business logic, the interfaces, models, commands, queries for CQRS mediator, the validators from Fluent Validation, custom exceptions and mediator pipelines, which are all present in the common folder. I think you see the rest. Let's open that interfaces model folder. And there's a lot of interfaces. The ID from that is quite genius, I would say. So the application layer, the business logic, uses most of these abstractions, these interfaces. But the actual implementation likely lives a layer lower. And these implementations likely depend on framework dependencies like ASP.NET Core or Entity Framework or Identity Framework and so on. But these abstractions are completely free from those. So the business logic stays clear of those kind of dependencies. So as you can see, independent of frameworks, which is the application layer. Let's take a look at one of those features just to illustrate what I just said. Let's take the breeds and let's take a command, and you'll likely see it use the abstraction of the database, like data context, without having in theory, without having the dependency on Entity Framework Core. So your .NET Web API, which lives in the presentation layer, can then reference the application layer and have the implementation of the actual DB context The API is then the place where both the abstraction and the implementation come together and get resolved, a bit like an add scoped of an interface and a service. It's a bit similar, but that would be the iData context and the actual data context, which is pretty cool that the abstraction can live in the higher layer while the actual implementation lives in the lower layer. The point of that being that the implementation likely depends on, for example, the API, the ASP.NET Core Web API, maybe MVC, have that dependency. And if you were to put the implementation in the actual business logic, so in the application layer, then you would have to drag that ASP.NET Core dependency or MVC dependency all over your business logic, which would make that only .NET Web API project can use your business logic. So if you were to then add a console application or a background worker service that doesn't have those ASP.NET Core MVC dependencies, then you would get all kinds of errors. You just couldn't access the business logic. It could even be a Blazor server project that wants to reuse the business logic, and if there was all kinds of MVC dependencies in the business logic, then that would be pretty troublesome for the Blazor server project. So the application layer holds interfaces that are implemented by outside layers. And as I showed you, all the business logic is there. So the feature folders is what I call these, that hold the commands and queries from the CQRS pattern. Also the DTO, the data transfer objects. And in the common folder you will find behaviors, the mediator pipeline behaviors, and much more. Let's move on to the infrastructure layer. This layer contains all external concerns, accessing external resources such as file systems, web services, SMTP, mailer, and so on. If, for example, the application layer has some business logic that uses this SMTP mailing service, then the interface of that SMTP mailer will live in the application layer, while the actual SMTP mailer implementation lives in the infrastructure layer, which makes that the infrastructure layer depends on and only on the application layer. Let's take a look at the services, like the email service. And there we see the SMTP and the IMAP implementation for sending emails and reading from IMAP servers. And this one implements the iEmail service coming from the application.common.interfaces. It also holds the actual data context and the configuration for identity framework with all of its dependencies on identity and entity framework. For example, this ASP.NET Core identity, the identity user. And this is another cool thing. So this identity user, you don't see Jason Taylor in the entities ever make a relation to this object because of the extra dependencies that would bring along. So if we take a look at the entities in the domain, for example, the user profile, you would see a string user ID, but you'll never see a identity user reference to keep that identity framework core dependency out of the domain and out of the application layer. Then lastly, you have the presentation layer, which is most likely the API or MVC project, or can even be the single page application, the Blazor server, you name it, Razor Pages. This layer depends on both the application and the infrastructure layers, but the dependency on the infrastructure is really only for accessing the implementations like the data contexts and these things to resolve those abstractions used in the application and the business logic. So that was a brief overview of what this template contains, what each layer contains, but there's so much more value to be found in this template. Let's now talk about how I and why I slightly shifted away from it. And I'm very grateful that I could shift away from it, that I could adapt it to my requirements. And that's because Jason Taylor really did his best to keep all options open, to, for example, use another database or whatever you need. It's needless to say that Jason Taylor has helped a lot of developers build better projects, improve their understanding about software architecture, and the development of modern .NET application as a whole. So now these developers can build well-architectured projects that will likely last longer and even help out shelters and shelter dogs in their area, like the application I built. It's some kind of Tinder for shelter dogs. This is my first project I started with the clean architecture template. But once I had this application, I wanted to provide more value to the dog world. So besides allowing new dog owners or potential new dog owners to adopt a dog and find the shelters, their local shelters, I also wanted to group or centralize the dog parks, the dog meetups, so like all kinds of fun things to do for dog owners, even services related to dogs and shops related to dogs. And the project grew and grew, and it no longer made sense to put everything in one layered architecture. So I took things apart, and to take things apart, it no longer made sense to follow the exact domain, application, infrastructure, presentation layers, because the interfaces folder became flooded with a lot of interfaces, as well as the features folders. A lot of features that it didn't make sense to put it all in the application layer. The same for the entity and the same for the data. It didn't make sense to put it all in one database, for example. So I took things apart, and the result looked more like the setup I showed you in a video about 8 months ago. So this pet adopt would be the application that you just saw, the Tinder for shelter dogs. And then what I mentioned about the dog shops, services, meetups and all that, I then extracted out to a pet social project, which follows a similar setup with its own database, its own API, its own shared components, and its own single page application. As the domain layer, for me, didn't hold much more than some constants, variables that I would reuse across both backend and frontend projects. And then only the entities, which I just moved to their own database layer. So I basically moved those into the infrastructure layer. And then I even moved out the identity stuff into its utils, even another separate project, to prevent duplicating the user tables in both the pet social database and in the pet adopt database, and to have this shared SPA hold the authentication components, which would then be implemented in both applications, front-end applications, and so on. And I took it even further apart as my projects grew. And I even divided this pet social project into 4 different ones: the pet event, which holds the meetups, the pet park, the pet service, and the pet shop. That said, let's check out my current setup, my monorepo to hold a lot of projects inspired by the clean architecture setup, but slightly adapted. So I no longer have a domain layer, since that didn't make sense for me. I moved the entities out to the database layer, which previously was the infrastructure layer. But I made the decision to use Microsoft SQL Server and not to change that anytime soon. So this database layer holds both the entities, but also the interface of the DB context and the actual DB context. And then the features, which was previously the application layer, references this database project. So takes in that entity framework dependency, which is not as clean, but it's my decision to depend on that. As there was one tiny criticism, I think, on Jason Taylor's template, which was the abstraction on the DB context did use these DB sets, and these DB sets come from the Microsoft Entity Framework. So Jason Taylor's application layer was actually already depending on that Microsoft Entity Framework core dependency. So it was actually 90% independent of frameworks, that application layer. Then you would have the API and the worker, basically the presentation layer, depending on the features and implementing the database. Or just the features, because that references the database. And then I made one more, which you could actually compare to the domain layer, but that was just some kind of top shared layer. You could really compare it to the domain layer, but that just holds my constants, which are constants or enums or things like that, and the contracts, which are basically my DTOs, my request and response objects, my data transfer objects. And I move those there because I want to reuse those in both the backend projects as in the front-end projects. And you could even add a Fluent Validation validator that you could then reuse in both in the front end as in the backend project. And what I then did was have the commands and queries inherit from the request DTO. That's an extra step, but it didn't feel right to me to use those query and command objects in the front end, since then your front end would depend on your application layer, which there is no reason for. unless your front end, your front end is a Blazor server project that directly accesses the business logic and does not go over HTTP, for example. So then I have the shared SPA, which is a Razor class library and is only implemented in the actual Blazor applications, so the single page applications. Each of these layered projects have a shared layer which just holds the configuration, whatever is applicable on every, for example, every features layer. So the pet event features has a configuration for, let's see, the pipeline behaviors of mediator, some kind of shared mapping from automapper, the exceptions, some configuration and behaviors that are applicable on every features project. So all of my projects kind of follow the same structure. I'll show you the complete schema in a bit, but let's first talk about the libs, the libraries, which are basically just some wrappers around external, how do you say it? External concerns like a payment service, a payment processor like Stripe, or a Google API, or a blob storage, so the SDK of Azure blob storage, and so on. These libraries, they don't depend on anything, so they're kind of, they were supposed to be in the infrastructure layer, but I took those out. I separated that infrastructure layer in libraries and in database projects. So I made that separation. So then I have clean, reusable class libraries that I can just plug and play into. Let's say if I start another project that also wants to access the Google APIs or the blob storage or Azure Service Bus, then they can just plug and play these modules, and I don't have to go into an infrastructure layer and take everything out that I want to reuse. And then I did not talk about the utils one yet. I did show that in the scheme you saw before, so that holds the authentication. So to make sure I can use the same user credentials to authenticate with all my different applications, so with all these below applications. I didn't want the user tables to be duplicated for every project. So I separated those out to its own database, its own API, and that holds features for example, authentication, but also for payments with Stripe or something else. That then implements, of course, that library to access, to make a HTTP request to Stripe, for example. And other things that didn't make sense to have in an actual project, an actual application. For example, metrics, and the payments I already said, authentication, and some other newsletter subscribers that's not specific to any application. But enough of that, let's head over to the scheme. This ops project, you don't have to, just ignore that. That's more internal operations. Just to run some things locally. Did I talk about everything? I think so. Let's head over to the diagram. Pew! So the setup you saw before in the video evolved to this. So basically just the pet social project split up into pet service, pet shop, pet event, pet park, and the rest is kind of the same. I'll zoom out a little bit. It's just a message broker, Azure Service Bus in my case. Also, you don't see the shared layer on here because I wanted to keep it a bit tidy. And I didn't draw all the lines, but all these single page applications are allowed to access any of these shared SPA layers, but then I would have to draw all the lines, but I didn't do that. These still, so each domain, as you could say, each application has its own API. These are not microservices, not in the way you would understand. There are clear boundaries between each API, so they're not communicating internally. Everything happens, so only the shared single page application layers can have their own HTTP client configured that can call their respective APIs. You won't see the pet adopt call the pet service or the pet service API call the pet adopt API. You won't see any of that. In the scenario that one API would have to communicate to another API, I don't do that directly. I use a message broker, the Azure Service Bus, to then, so the API 1 sends a message with some metadata, and then the worker, the background worker, which will run every 5 minutes to check for messages, will then process the message with that metadata and do whatever it needs to do with that data. And so I do that instead of having the utils API directly communicate to the pet adopt API. If it were the case that the front end calls has to change the state of multiple databases by calling multiple APIs, then I'll let the front end be the orchestrator. That means the front end will do a post, for example, to the pet adopt API. And then I won't have the pet adopt API post to the pet event API. I rather have the front end either simultaneously call both APIs, since the front end will have a combination of the front end will likely have all of the data at its disposal. So it can then orchestrate the calls, then first call the pet adopt API, and then either simultaneously call the pet event API, or first call the pet adopt API, and then afterwards, maybe with the result of the pet adopt API, call the pet event API. And just like that, the frontend is the orchestrator. I don't do any internal communication between the APIs. Inter-service communication, I don't do that. I don't have that requirement yet. I do sometimes make the frontend orchestrate when it doesn't really make sense to have it the responsibility of the frontend. For example, a user creates a new pet service, let's say, and then an email notification has to be sent to the system administrator. Instead of making that responsibility of the pet service API, I let that email notification be triggered by the front end, which is a bit unconventional. But the reason being, first, the pet service API cannot directly call the utils API. The utils API would have the endpoint to send an email. Also, this pet service API would not have all the data necessary to compose a proper email holding the user info, holding the more info about pet service. Yeah, that it has, but yeah, maybe some other data coming from other APIs. Yeah, it's not possible with that pet service API, which is a bit unconventional and probably a use case for microservices. But yeah, I'm aiming to keep things simple and will not go for any complex architecture, any complex setup, as long as it is not really required. I might go microservices if I have tried all other options. And then lastly, there were some features, there was some data that every application needed, but also, yeah. And then lastly, something not ideal in this utils project, I put the dog breeds, the friendships, pet profiles, since those were also things I didn't want to duplicate in each of these other databases. So that's become a bit of a mixture of things I could not really place in one application, which originated from, most likely from the pet adopter, the pet social project, but then had to be applied to multiple projects. A bit similar like the authentication stuff. So that was all about how I adapted the clean architecture ID, the clean architecture setup of JSON Tailor to fit my own requirements. These will of course be very different requirements than your own. It's likely that you won't have 4 or 5 projects that are that similar like mine are. I will do that in the next video series about creating my own brand website for the Keep It Simple Stupid YouTube channel. In that video series, I will try my best to innovate as much as possible. I'll likely try to use the minimal APIs and talk about those. I'll take a look at what .NET 7 and .NET 8 has to offer. I think there's some interesting things about authentication, that there is now some way to just almost plug and play all the authentication endpoints, like logging in, registering, confirming a user. And then let's see how far the .NET 8 Blazor setup is, the United Blazor, where you allegedly could have the Blazor WebAssembly and the Blazor server in one project and use both client as server-side capabilities. And I might even add in some vertical slicing to the best of my ability. Because an issue I'm having with these horizontal project setups is I cannot easily copy over things I already built to a new project. I would have to copy over each file separately to the right layer and all that. So wouldn't it be cool to copy over the entire solution folder, having the feature from the front end to the back end as some kind of plug and play module? So make sure to subscribe to stay up to date with all the wild ideas I'll be working on next. And leave a like. Ciao.